Okay, so we are going to jump up to 5.1, which I think you guys will like a lot better than the last chapter, especially this section. Maybe not later on. But, all right, so we're going to do 5.1, which is systems of two equations. And I'll bet you guys probably already know how to do these. If I had two x plus y equals 1, and I have 3x plus 4y equals 14. I bet you guys already know how to solve that. So Javi, you already know how to solve it, don't you? Okay, so two equations, two unknowns. There's two ways to solve. Tyler?
Once you solve the top of the y, we can subtract.
Yeah, we can subtract 2y, and then therefore this would become 1 equals 1 minus 2x. So this is referred to as substitution. Substitution. Okay? Now we're going to substitute that where? Into the bottom equation where we've got the y here. And so in that case it will be
3x plus 4 parentheses 1 minus 2x equals 14.
okay. And then this becomes 3x plus
3x plus 4 minus
4,
8x.
8x equals 14.
And then negative 5x equals 10.
Okay, so subtract 4. So negative 5x equals 10. Divide by negative 5. X equals negative 2. So we've got one answer. Now how do we get the other one?
You plug that back into.
Plug that back into here, right?
Yeah.
Okay, and so then we're going to get y equals
1 minus 2 times
negative 2. 2 times negative 2 times negative 2 is
negative 4.
positive 4.
Oh, yeah. Sorry.
So 1 plus 4 is
1 times 4 is 4.
we good? Okay. Does that make sense? Okay. Do you remember that now, Javier? Coming back. Okay. So that's one way, one method to solve is with substitution. Another method is with elimination. Elimination. So let's talk about that. Let's say that I had 3x plus 2y equals 14 and x minus 2y equals 2. So since Tyler goes, yeah, you want to do this one?
Yeah. So the y's cancel.
Yeah, so we can just add two equations together. Those are going to cancel. We're going to get what?
4x.
4x equals
16.
16
Divided by 4.
divided by 4. X equals 4. And then what do I do with that? Which one?
Doesn't matter.
Does it matter? What do you guys think? Does it matter? Doesn't matter. So which one do you want to put it in?
3x.
The top one? 3 times 4 plus 2y equals 14. 3 times 4 is 12. So we can subtract 12. 2y equals 2. Divide by 2. Y equals 1. Okay? All right, now this does talk about solving equations graphically. Now, I'm not going to worry about that because it's too hard to solve it graphically, but I do want to point out this one thing. There we are. Okay? Now, I don't know what these two look like, but let's just pretend that they look like this and this. Okay? Now, the idea here is if these are the two lines, okay, then this would represent x equals 4 and y would equal 1. That's where those two lines intersect. Okay? So, anyway, that's how, so the idea here is when you have two equations, two unknowns, these are both straight lines. Wherever they cross, that's where they're equal to each other. Okay? Question? No? All right. Now, let's do another one of these just to make sure, and I'll let you pick which way you want to do it. 8x minus 2y equals 5, and negative 12x plus 3y equals 7. Okay. Let's pick on Hallie. How would you solve this one?
I would get the y by itself for the first equation.
In the first equation, okay. How would you do that?
Subtract 8x.
So if we subtract 8x, we're going to get negative 2y equals 5 minus 8x.
Well, that's going to be messy.
That's going to be messy because we're going to get a fraction, right?
Yeah.
Okay.
Can I change my method?
You want to change your method?
Yeah.
What do you want to do?
Can you multiply the first equation by 3, the second equation by 2?
Okay, so you're going to eliminate the y's.
Yeah.
So we're going to multiply the top equation by 3 and the bottom equation by 2. So the top equation is going to be 24x and 6y equals 15. And the bottom equation is going to be
Negative 24 plus 6y equals 14.
okay. So those will cancel, but those are also going to cancel. And I'm going to get 0 equals
1.
no,
Oh, adding them. So
29. And when is that true? Only when I owe you money. Okay? All right, so what does that mean? No solution. Okay? Now, graphically, do you guys know what's going on? They're parallel lines, okay? So graphically, they're parallel lines. They're never going to intersect. Okay? Does that make sense? All right, one more that I would like to do just really quickly. What if we had 3x minus 6y equals 12 and 4x minus 8y equals 16. How would you solve that one, Bailey? It must be your turn. Get rid of the x's first. Okay. So we're going to multiply the top by negative 4 and the bottom by 3. Okay. So this becomes three times 16, 48. So that eliminates, and so does that, and so does that. So I get 0 equals 0, which is a true statement. So what does that mean? Okay, so here's what I would like you to say on your test. This is a little bit different than the book. I would like to say these are dependent. Because especially it's really visible here. Essentially what we've got going on, I'm not going to draw this accurately, but essentially we've got a straight line. And then we have another straight line that's on top of it. And my other class, they mentioned all real numbers. And I think what they do, all real numbers is technically not correct because that number is not a solution. you do have infinitely many solutions. Any solution that fulfills this line is a solution. Now, so in the book, they have kind of a weird answer in there. Here's what I'd like to say. It's a dependent system. Okay? So just write dependent on there and you'll be good. Okay? So, gosh. Pretty good. Okay. Well, quiz tomorrow is going to be on 5.1, and we're going to, I'm going to try very hard. I've got my review almost written. I just want to check it out because I didn't look at it very closely. I'm going to try, if it's not up within, say, 2 or 3 hours, text me. I'm going to put you in charge of that, okay? And then remind me to put that up, okay? And see y'all tomorrow.